Oh, sorry guys, you caught me reading the paper. Like to keep up with what's going on in the world there. So this is our first attempt together at doing the flipped classroom, kind of working through it and explaining it. So I guess the first part we need to discuss is this layout right here. This layout is what we're going to call Cornell style notes for math. We're going to leave this section over here maybe for extra work, maybe for notes or things that we're thinking about as we're trying to work through this, try to organize what we're doing. These warm-ups here, 1 through 5, we want to do number 1 on Monday, 2 Tuesday, so on and so forth throughout the week. Now the examples I'd like for you to do all by Tuesday in this case. Now, don't get me wrong, this is a lot of work. So what's nice about this video is you can pause me at any time, or you can pause the work once it's done, write it all down, skip over to the next one, then come back and just listen to it. However you do it is up to you. Okay, some of this stuff, guys, is going to seem really, really simple, and it should. This is all review. This is the prerequisites to calculus. Okay, we're going to be reviewing for about the first 3 to 4 weeks before we move into anything that's really new. So, let's look at solving linear equations. So, if I want to solve this linear equation, really all I'm going to do is I'm going to subtract 10. Subtract 10. 2x is equal to negative 10. Divide by 2, so that x is now equal to, oh, that's a 10, got ahead of myself, is equal to negative 5. Now here's the thing about calculus. The hardest thing in calculus is algebra. And we're going to get to some stuff to tie into algebra before the end of these examples. Your work is important, especially in this class. You might get every problem right, and I'd still give you a 50 on a paper if I don't see your work. Your work will count as half of your grade, and that's very, very important for you to understand. Alright? So, here's another linear equation. It's just a little more complicated in the way that it looks. This is what we call a fractional expression. So, if I want to get rid of this, well, I need a common denominator. The least common denominator I can think of is 12. So I'm just going to multiply basically everything by 12. 12 times x over 3 plus, I'll make it 12 times 3x over 4 equals 2 times 12. Can't leave this out. Alright. Well, when I rewrite this, it basically becomes, cancel there, 4x plus, this cancels, and 3 times 3 is 9, so 9x equals, what is that, 24? Okay. Add those two together, and x is now what? There's 13 of them. 13x equals 24. Divide by 13, and you're left with x equals 24 over 13. So maybe you don't understand what I did right there, and you need to come over here and write down this little note that says use least common denominator, LCD, to start. You know, maybe you looked at that problem like, oh my gosh, I don't know what I'm doing, and then I say that and you're like, oh, okay, well, that makes a little more sense. You know, whatever it is that can help you organize your thoughts. Okay, so we're going to move on to example number 3. Example number 3 is an extraneous, I can't say it, I'm sorry. It's the same thing as a fractional expression, but our fractional base is a form of a linear equation. In this case, we have x minus 2, x plus 2, and x squared minus 4. Well, the least common denominator is what's going to be able to multiply together and do this. If you check this real quick against these, you'll realize that x squared minus 4, if I factored this, would come out to x minus 2 and x plus 2. So our least common denominator winds up being the x squared minus 4. But we've got to do it in such a way that we are using that divisional multiplication to kind of help us out. Alright? And let me show you what that means. We're going to start with our first side, which is 1 over x minus 2 times, and I'm just going to use x minus 2, close, open, x plus 2 equals 3 over x plus 2 times, of course, what is that? X minus 2, open, x plus 2. Now my last one, the 6x over x squared minus 4, I'm just going to multiply that by itself, x squared minus 4, to make this easy. So when I'm looking at this, I go, okay, get rid of this and this. Okay, get rid of this and this, get rid of this and this. I'm canceling fractions is all I'm doing. Well, now I'm left with 1 times x squared, which is 1 times x plus 2, so it gives me x plus 2 equals 3 times x minus 2, which gives me 3x minus 6, and then of course this cancels out, and 3x times, or 6x times 1 is 6x. And, oh, I missed a notation right here. This is minus, so minus 6x. That little minus goes right there, and I forgot. So now we're just going to combine like terms and solve for x. So when I combine like terms on my left side, or on my right side first, I wind up with x plus 2 equals a negative 3x minus 6. Alright, so I'm going to move my x's over here and my whole numbers this way. So when I move my x's, I add 3x to both sides. It gives me 4x, and I take 2 away from both sides. It gives me a negative 8, and I'm allowed to divide now so that x equals a negative 2. Final answer. Okay? Not too terrible. It could be worse. Let's slide on to example number 4. Alright, so example number 4. We're looking at quadratic equations by factoring here. It's not anything that you haven't already done before. Just basically working through problems. First part right here. 3 we need to move back over for, got the split for you for A and B. We need to move the 3 back over. Well, that's taking 3 away, so let's go ahead and rewrite this as 2x squared plus 9x plus 4. So if I think about all the numbers that are going to give me this, I'm going to start right here. I'm going to start with my parentheses. One of these has to be 2x and one has to be x. Okay? Both my numbers are positive here and here, so I'm going to be adding. So now I think of the multiples here that'll give me this, which are 1 and 4, or 2 and 2. So if I put 1 here and 4 there, then 1 times x is 1x, and 2x times 4 is 8x, and if I add those together, 1 plus 9, or 1 plus 8 gives me 9. So my factors in this case, 2x plus 1 and x plus 4. Now I set these both equal to 0. Last one, x plus 4 equals 0, and solve. So that it winds up being, in this case, minus 1, 2x equals negative 1, therefore x equals a negative 1/2. And on this side, it's just subtracting 4, and I'm done. So x equals negative 4. Not too terrible right there. Next one's a little bit different in that we can start with our 6x squared minus 3x, and then we don't have a constant. We don't have a whole number there to mess with. So here's what we can do. We can take out an x, and we can take out the multiple of 3 from each of these and rewrite this as 3x, open parentheses, 2x minus 1. Well, we can set 3x equal to 0. It doesn't matter what we do, x is going to wind up equaling 0 there. And then we can also set 2x minus 1 equal to 0, and we're going to start by adding our 1 to each side, so that 2x now equals 1, therefore x equals 1/2. Two solutions, 0 and 1/2. Not too terrible. Next set is talking about extracting square roots. So again, an a and a b, so we can work both sides. Well, if I want to extract square roots from 4x squared equaling 12, first thing I'm going to do is just go ahead and divide this by 4 on both sides. Make that real easy. X squared equals 12, and to extract the square root, I'm basically going to take the square root of each side, so that x equals, oh, I'm sorry, that shouldn't be 12, that should be 3. 12 divided by 4 is 3. Square root of 3 can be positive or negative. Square root of 3. If you wanted to write it as the fraction part, or as the what is it called, the radical number, whatever it would be, 1 point whatever, using your calculator, you can. That just takes up a lot of space. Alright, it's easier to leave your answer in this kind of form. Looking at this next one, we can go ahead and say x plus 3 squared equals 7. Go ahead and start with your original, and let's take the square root of both those numbers. That leaves us with x plus 3 is equal to, well, it's equal to plus or minus the square root of 7. Subtract 3 and subtract, oh, that should have started out minus 3. I messed up right there. So that should be minus 3. That should be minus 3. So x minus 3. So we should be adding 3. I apologize. Messing up a lot today. X equals a positive 3 plus or minus the square root of 7. Final answer here. Final answer here. Not too bad. We can move on. Alright, number 6. You guys probably remember this from Algebra 1, completing the square. Completing the square with a leading coefficient of 1. So, let's go right here. Let's start with our original problem, which is x squared plus 2x minus 6 equals 0. First thing we need to do is move our 6 to the other side. Alright, not too bad. So x squared plus 2x then is equal to positive 6. So, next thing we want to do to complete the square is we're going to take half of 2 and square it. We're taking half of this number and we're going to square it. Let me make that little note right here when we do it, so that x squared plus 2x plus 1 squared equals 6 plus 1 squared. This way it doesn't quite mess you up. Right here is what we're looking at. We're taking half of b and we're squaring it. That number, of course, is b too. So when we go ahead and work this through, we wind up with a perfect square of x plus 1. This is the factor squared, equaling 7. Now, of course, I can take the square root of both sides. So let me come up here and do it. X plus 1 squared equals 7, and I'm going to take the square root of both sides, so that x plus 1 equals the square root of 7. That's, of course, plus or minus. And then go ahead and subtract my 1 from both sides, so that x equals negative 1 plus or minus the square root of 7. Final answer. Again, not too terrible. Sometimes they get to be a pain in the butt, but we'll survive. So now we're completing the square when the coefficient is not the number 3. Okay? Ugh. Sleepy, sleepy, sleepy. So, start with 3x squared minus 4x minus 5. Again, first step is still the same. We're going to add 5 to both sides so that we wind up with 3x squared minus 4x equals 5. Our next step is to figure out, our next step is going to be to divide by our leading coefficient. And our leading coefficient is 3. So we're going to divide this entire problem by 3. That way we wind up with a leading coefficient that is 1. So we wind up with x squared minus 4/3 of x equals 5/3. Okay? Right over here, this is one of those deals where you can say, you know what, hey, we divided by leading coefficient. And that way you know what's going on if you look back in your notes and you're trying to figure out what was this step and why did we do that. One of those notes. Okay? Always looking for a way to let yourself know what's going on. Alright, so when I redo this, x squared minus 3/4 of x. Now remember, we're taking half of this number and squaring it. Okay? So what is half of 4/3? Well, flip that upside down. 4/3. Half of 4/3 is going to be what? 2/3 squared. Right? So let's look at it like this real quick. 2/3 squared equals, of course, our 5/3 plus the 2/3. And you may not be able to see that part way over there, but that's okay. Squared. So when I work this out, x squared minus 4/3 x plus, what is this? 4/9. 2 times 2, 4, or I'm sorry, 2 times 2. 2 squared is 4, 3 squared is 9, yeah. 4/9. Same thing over here, 5/3 plus 4/9. I turn those thirds into ninths, that'll be 15. 15 plus 4 is 19/9. So when I go to work this, notice that when I go to factor it, it's going to be this number is the one we're going to wind up using. So the factor is going to be x minus 2/3 whole thing squared is equal to 19/9. Okay, when I take the square roots of both sides, it'll be x minus 2/3 equals plus or minus the square root of 19/9. And then the last thing is going to be to add 2/3. Sorry, that needs to show that it's minus, add 2/3 to each side. So I'm going to come over here to write my final answer. That way I'm not getting all the way down to my quadratic equations area here. So x will equal a positive 2/3 plus or minus the square root of 19/9. A lot of work, but the algebra is what we need to review. Again, the hardest part of calculus is the algebra. Alright, let's see. Example number 8, the quadratic equation. Alright, so for those of you who don't remember, quadratic equation is, what is it? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you can't remember, it goes like this: a, b, and c for our constant. We'll have to bring that c back over and rewrite our equation. So when we rewrite this, it's going to start as x squared plus 3x minus 9. Again, a is 1, b is 2, and c is negative 9. I'm sorry, b is 3, and c is negative 9. So when I rewrite this into this equation, it becomes negative 3b plus or minus the square root of 3 squared minus 4 times 1 times a negative 9 all over 2a, and a again is 1. So that's how I'm going to find my two answers. I work out the inside of the square root first. If I put all this together real fast, 9 minus, actually it would wind up being plus 36. 9 plus 36 is going to be 45. So I wind up getting negative 3 plus or minus the square root of 45 over 2. And if I factor this out, I can get a factor tree of 335. Okay, which means this 45, I can get 3, and that's going to turn into 15, 3, and that's going to turn into 5. Well, taking out, circle 2, cut out 1, 3 comes out, 5 stays in. So my final answer here would be negative 3 plus or minus 3 comes out, 5 stays in, over 2. So negative 3 plus or minus 3 times the square root of 5 over 2. Final answer. Okay? That's for multiple solutions. Okay? Let's look at one where you only have one solution. Okay? Again, A, B, and C. Well, I'm looking at this, and the first thing I can do is I can divide this whole sucker by 2 without any problem, and rewrite that as 4x squared minus 12x plus 9. That just makes it easier for multiplication and everything that I want to be working out, guys. So when I rewrite this, b, so it's negative b, well I've already got negative 12, so it's going to wind up being positive 12. Positive 12 plus or minus square root of 12 squared minus 4. A is also 4, and C is 9 over 2A, which is 4. So when I work all this out, that's 144. 4 times 4 is 16, and 16 times 9 is also 144. So it's 144 minus 144. Well, dang, that winds up giving me 0. 12 plus or minus the square root of 0, and my bottom will turn into 8. Well, this is a situation where it doesn't matter if we add or subtract 0, answer's still going to be the same. So when I do that, I wind up with just 12 over 8, reducing it. Well, 12 over 8, I can divide both those by 4 and get 3 over 2 equals x. Final answer. Not nearly as bad. Alright, so page number 4. Don't worry, we only got 2 more pages. Alright, this next one is solving a polynomial by factoring. Some of the stuff's really easy, some of it's really hard. Okay, this one's pretty easy. We're going to bring it together first and go 3x to the 4th minus 48x squared equals 0. First factor I'm going to do is I'm going to take 3x squared out of both of these. Okay? So 3x squared, well, 3 goes into 48 16 times, so I'll end up with an x squared left over here, but then I'll end up with a negative 16 here. Okay? Well, negative 16, factoring it out, again, 3x squared or 3x squared times x plus 4 and x minus 4. Perfect squares gives me my negative 16. 4 times negative 4 is negative 16. X gives me my x squared, and then a positive minus a negative of the same number cancels out that middle x, that single x we don't want. So then I solve each one of these. 3x squared equals 0, so we get a 0 x answer for that one. Then we get x plus 4. When I do all my work on that one, it'll change to negative 4, right? And then x minus 4, and when I do all my work on that one, it's going to change to a positive 4. So my zeros, x equals 0, 4, and negative 4. Not too bad. This just happen to be my factors. Next one's a little bit tougher. Not terribly. We just got to group everything together. And then we're going to wind up using our distributive property, probably in a way we haven't ever used it before. Okay? So I'm going to take this number, and this equation. First thing I'm going to do is I'm going to group this section together and this section together. Okay? And when I do that, I'm going to bring this negative inside and say we're adding everything together. Okay? So positive here, make that negative. So I can factor out an x squared here. So that this says x squared times x minus 3. There's a factor. Minus, over here, all I can take out is 3. And we'll pull that 3 back out and make it negative. Well, when I do that, a negative times a negative gives me positive. So this 9, the only way to get back to positive 9 is to have a negative 3 there. Okay. You notice these two are the same, right? Well, we only need one of those. What we have to do is take the leading coefficients here, the distributive coefficients, and we're going to combine our distributive property. Okay? So instead of multiplying x squared in all the way here on this one, and then negative 3 all the way into this one, since this is the same thing, let's look at it like this. X minus 3, if I were to multiply it by, oh, I don't know, x squared first, and then multiply it by 3, all we're doing is distributive property, but we've manipulated the way we can use our equation. Okay? So this is not a perfect square, and we can't get it any better. X minus 3 equals 0, add 3, add 3. Right? So x has one root at 3. This one, x squared minus 3 equals 0. We're going to add 3 and add 3. We have an extra step of taking the square root of both sides, so that x equals plus or minus the square root of 3. So I wind up having 3 answers. I have x equals 3, x equals negative square root of 3, and x equals positive square root of 3. Final answers. Is it terribly impossible? No, not really. Does it require a lot of thinking? You better believe it. Okay? Oh, man. Move on to number 12 here. Number 12, good old radicals. Equations involving radicals. These are never enjoyable, but we can simplify what's going on here. Okay? Start with A, and probably going to have you skip B. This is going to require a lot of work. We'll do that one in class together. Probably, in fact, I'll do it tomorrow before y'all ever see this video. So, square root 2x plus 7. I want to go ahead and move this x over. So I want to make this x positive x plus 2. Because if I move it over, I'm going to add x to both sides. To get rid of a radical, to get rid of a square root, you've got to square everything, right? So 2x then plus 7 is equal to x squared plus 4x. Yep, 4x plus 4. Now we're going to combine like terms and factor it out. So I'm going to go ahead and subtract 7 from both sides, and then I'm going to subtract 2x from both sides. So I wind up with x squared plus 2x minus 3. Well, I can factor that pretty easy. My factors are going to be x, alright? And because I have a positive negative, one's going to be plus, another x, and the other one's going to be negative. Positive, negative, positive, negative. Okay? Now, there's only one set that's going to give me this, and that's 1 and 3. When I multiply that back together, I need to just make sure that my positive is my bigger of the two numbers, and I messed that up. So let me scratch that out and change it. 3 and 1 here. So x plus 3 equals 0, and x minus 1 equals 0. When I set those two equal, x winds up being negative 3 or a positive 1. And then again, this is all for A. We're going to do B in class. Save us a little time on the video, and we can move on. All right. 13. Now we're working with some crazy radicals, to be honest. If you can't remember what this means, it means squared and cubed root. So when I write that out, it means the cubed root of x minus 4 squared equals 25. Okay. So same way we had to get rid of the radical earlier by squaring both sides, now we have to cube both sides. Now this is one time where I say go ahead and use a calculator. It's going to make your life easier. Alright. So what I wind up with is x minus 4 squared, because that's what's left inside the parentheses, equals, what is it, 15,625. Okay? From here, I can do my squares and take the square root of both sides. Square root and square root. Seems kind of funny that I had to cube everything to square everything, but that's what we got to do to get rid of that. So x minus 4 is equal to, and again, use your calculator right here. This is okay. You're going to get plus or minus, because it's a perfect square, of 125. So then, my answer becomes x, add 4 to both sides, equals 4 plus or minus 125. Terribly hard? No. But you got to do what you got to do. Okay, last one. And I apologize again that this video is so long, guys. We're going to look at the absolute values. Okay? So when you have absolute values, you're going to have not one, but two different sets of possible solutions. Okay? So first thing I have to do is assume that everything's positive. Okay? And I'm going to write it out as just x squared minus 3x equals a negative 4x plus 6. This is one I probably should have done this number on, because one side has to look like this, and the other set of answers is going to be open parentheses x squared minus 3x close parentheses equals 4x, or negative 4x plus 6. So when I'm working this right here, I'm just going to combine like terms from both sides. When I bring everything over, I'm still going to have x squared. Let's see, x squared, positive, negative, so that should be a positive x minus 6. Okay? Factor it out. Factors, again, positive and negative, so one's positive, one's negative. Both will start with x, because x times x gives me x squared. 2 and 3, and I need 3 to be larger because my middle number is positive. So on this side, x winds up being equal to negative 3 or positive 2. Remember, you're just flipping those two numbers to opposites. Other side, I'm going to distribute here, so it's a negative x squared. Everybody got that? So it's a negative x squared minus, so that becomes plus 3x plus 6. Oh, I'm sorry, plus 6. That's just distributing it through. So that's a positive 3 equals negative 4x plus 6. Now, instead of bringing this stuff this way, I'm bringing this back across. I'm going to move the x squared first so that it becomes a positive x squared. Then I'm going to subtract 3x from both sides, so it gives me minus 7x. And then I've got a positive 6. Again, I can factor this using the same rules. So it's positive and negative. X is in front. My larger number here is going to have to wind up being my negative. Actually, I've got that messed up. This side is positive and the middle is negative. They're both negative. Only way to get those to add together is going to be with 1 and 6. So my answer winds up being x equals a positive 1 and a positive 6. Alright, so the very last thing that you need to do, I want you to search your house for appliances that model the basic ideas of a function, which means you put something in and you get something out. Be creative. And P.S. if anybody can bring Coach Jackson a cup of his favorite output, you're going to receive an extra 10 points on the first assignment. See you soon, guys.